All right, looking at this free response question, this is similar to what I expect the 2020 AP exam to look like because except for one problem, the calculator is not really going to offer a huge advantage. We have f of x is differentiable, twice differentiable, with an initial condition f of 3 is 7. We're given f prime. They do tell you that f prime is a line or a line segment from the point x equals 1 to x equals 6. So that'll come into play. And then they give you another function h right here. A is a fairly straightforward question. There's a function g, find g prime of 2. So let's start with g prime of x, which would be a product rule with two chains, two chains in each piece of the product. So derivative of f of x squared minus 1 would be that. Leave the h function alone, plus, and then leave f of x squared minus 1 alone. And then the derivative of h of 2x would be h prime of 2x times the derivative of the inside, which is 2. Now we plug in 2 and see how we can get all of this information. So that'll be f prime of 3 times 6, h of 6 plus f of 3, h prime of 6, and 2. Okay, f prime, we are given the graph of f prime, and at 3, f prime of 3 is 2, so we have 2 times 6. H of 6 would be 12 minus 5, that's 7, plus f of 3 was given, that's 7. H prime of 6 would just be 2. H is linear, so its derivative will always be 2 times 2. And on the AP exam, I would stop there and move on because you cannot get any more points for cleaning that up. However, on this problem, since I'm working this out for y'all, I'll go ahead and simplify it. 12 times 7 is 84, plus 14 times 2 is 28, and that would give you a final answer of 112 if you choose to simplify it, which you shouldn't. Okay, so in part A, I made a mistake, and several of you have called me out on it, so I figured I should fix this. For whatever reason, I decided that 2 times 2, because I am plugging in x equals 2, I decided that 2 times 2 was going to be 6 on multiple occasions, so I need to fix that. The only thing I can think is that when I plugged in 2 here, I got 3 for f prime of 3, that 3 was stuck in my head, and then I continued to use 3 throughout. So I need to erase that. I need to erase h of 6. I need to erase h prime of 6. And then that means this 6 will be different. That h of whatever will be different. H prime may be different. And I think that was it. So let's go in and fix those. So 2 times 2, we'll change that to 4. I think that's probably the better answer for 2 times 2. And now I need to find h of 4. And at 4, oh, h is up here. At 4, h would equal negative 1. So h of 4 is negative 1. H prime of 4 is actually not going to change. That'll remain 2. So now I need to come down here. That's going to alter the simplification of it, which is not necessary. 2 times 4 times negative 1 is negative 8. 7 times 2 times 2 is 28. And negative 8 plus 28 is 20. So you should have gotten an answer of 20. And then one last point, the way I corrected that, and I was trying to do it quickly, is not how I would recommend you correct your work on the AP exam. It's very dangerous to go through and try to follow a mistake throughout multiple steps of work. So if this were the AP exam and I was not hard pressed for time, I would actually have scratched out everything starting with this line and just started over. That's the safer way to do it because tracking an error through multiple steps can be very tricky, and probably just better to go ahead and start over from that step and correct it. So on to part B. All right, for B, we're trying to find the value of f of negative 1 given that definite integral. And so what I assume will happen is that as I work this problem out, f of negative 1 shows up somewhere in the evaluation of that integral. So let's see if that happens. First thing I'm going to do is h of x is not an unknown function. It is 2x minus 5. So I'm going to go ahead and plug 2x minus 5 in there. That will give me the integral I would come down here, 2 to 4 of f of 2x minus 5. And that is a good u substitution problem. We're going to let u equal 2x minus 5. du would be 2 dx. So this would create the antiderivative of f of, oh, I need to take care of my du. du is 2x. I'm going to squeeze a 2 in there with that dx and put a 1/2 out here. So that 1/2 would remain. And this would turn into f of u du, and then I'm going to convert my limits of integration. So my 2 and my 4, this is something that comes in handy. If x is equal to 2 and u is equal to 2x minus 5, u would be 2 times 2 minus 5, which is -1. And if x is equal to 4, then h would be 2 times 4, which is 8, minus 5, which is 3. And I have a typo here. That was f prime of h of x, and I only wrote h or f. So I'm going to put my f prime here, which makes this significantly easier because the antiderivative of f prime would just be f. And I can now plug in -1 and 3. And so that will give me 1/2 f of u, whoops, undo that, 1/2 f of 3 minus f of -1. And then they tell you that this answer should be 22/3. So now I can go ahead and put that 22/3 in here and plug in what I know. We know f of 3 is 7 because that was given. And I think I'm actually going to go ahead and multiply both sides by 2. So we have 7 minus f of -1 will give me 44/3. I'm going to double both sides, times 2 times 2. And then f of -1 would be 44. No, it wouldn't. It would be 7 minus 44/3, which I typically don't clean up. But 21/3 minus 44/3 would be -23/3. And again, on the AP exam, please do not go through those extra arithmetic steps, cleaning up, simplifying stuff. Turns out that knowing the value of f of -1 will help you in another part of this question, maybe part C. Yeah, I think it is. And part C kind of confuses me with the way it's written, because I've worked this problem out twice, and truth be told, I'm not sure where this piece of information is going to be used. I think there's an easier way to do it. I see one spot where I could use that integral, but this thing right here I think is more of a distractor. I'm going to ignore that. I'm trying to evaluate this integral, and just like the other problems, I know what h is, or the previous problem, I know what h is, so I'm going to plug in the actual function for h. And so I have the integral -1 to 5 of f double prime times 2x minus 5. And this is set up to be a parts problem. So we need to pick a u and a v prime. And I have to pick the f double prime to be v prime because, well, I guess you don't have to. It works out better that way. Okay, my bad. I shouldn't have said have to. You wouldn't be able to solve. You'll end up making the problem worse if you choose your u and v prime differently. So now I'm going to do my derivatives of u, and I see this is one of those great sexy problems where you can differentiate u all the way down to 0, which is called the tabular method. And this will open up to that parts shortcut as long as you can do the same number of antiderivatives of v, or v prime, which I can. Technically, because I finished with u double prime, I'm going to start with v double prime. You don't have to do that, but it just looks better. So the antiderivative of f double prime is f prime, and the antiderivative of f prime is f. And so this turns into 2x minus 5 times f prime of x. Multiply u times v prime, and then we will subtract the product of u prime and v. So minus 2 f of x. We're evaluating that from -1 to 5. And then we start plugging in. See if I have enough room here. So 10 minus 5 is 5. F prime of 5 minus 2 f of 5 minus, negative set. Whoa. Am I doing this right? Because I didn't get this last time I did this. Maybe I did. Negative 7 f prime of negative 1 minus 2 f of negative 1. So let's start plugging in what I know. F, so you have 5, f prime of 5. We are looking at f prime right now, and f prime of 5 is negative 2 minus 2. F of 5 is what we don't know, and so we're going to have to create a second setup to get the value of f of 5. And so on to the next one, negative 7. F prime of negative 1 is 6 minus 2 f of negative 1. And here's where having the value of f of negative 1 in part B helps out. F of negative 1 was negative 22 thirds. So now I can import that. So minus 2 times negative 22 thirds. I'll clean that up a little bit. So that's negative 10 minus 2 f of 5. That's negative minus negative 42 plus 44 thirds. And that is not at all what I got when I worked this problem just a minute ago, but hopefully I haven't made any mistakes. Maybe I made a mistake on the other one. So now we need to figure out what f of 5 is. And the way I'm going to do that is I'm going to take advantage of the fact that I have f prime. I have an initial condition for f. And on this interval, I have my initial condition of 3. I'm looking for f of 5, and both of those are on the linear segment of f prime. So I can get f of 5 by doing the net change approach. So I know f of 3. I'm going to add to f of 3 the area from 3 to 5 under f prime. And this is really nice because if you look at the area from 3 to 5, 3 to 4, and 4 to 5 have the exact same area in magnitude, yet one is positive and one is negative. So f of 5 is just going to be 7 plus 0, or 7. I'm going to come back over here and plug that in. 2 times 7 is 14 minus negative 42 plus 44 thirds. And I'm going to stop there. I don't think there's a need to simplify this. And yeah, I'm double checking my work because I didn't get that same answer when I worked this just a few minutes ago. But I think this is right. I think I made a mistake on the first time. All right, so moving on to part D, and this one's a little bit of a booger. Again, just like the other problems, I know what h of x is, so I'm going to plug h of x in. And to make this one a little bit easier, because this one does not look like it's a good parts problem or U sub or something like that, I'm going to find the equation of the line that represents f prime from 1 to 6, because I am working on that interval. This time we're only going from 1 to 2, but from 1 to 2, I am part of that line. And so the line, the linear equation right here, that is a slope of negative 2. And if you followed that slope up, that would have a y-intercept of positive 8. And so this is my equation for f prime on this linear segment. So I'm going to substitute that in. We'll have the definite integral from 1 to 2, 6x over negative 2x plus 8 times h, which is 2x minus 5. And this will be an integration by partial fractions problem. Before I dive into the partial fractions, I notice that I can factor a 2 out of 2x minus 2x plus 8. As a matter of fact, I will take out a negative 2. That'll leave me with x minus 4. And then the negative 2 and the 6 can reduce to a negative 3. So I'm going to change my problem to 1 to 2 of negative 3x over x minus 4, 2x minus 5. I'm always looking at algebra things that can be done to make the calculus a little bit easier. You should never turn off your algebra brain. Don't just dive into the calculus. While it would work, a lot of times it can make things a little bit uglier. So now we have to do the partial fractions. So negative 3x over x minus 4 times 2x minus 5 is going to equal something over x minus 4 plus something over 2x minus 5. And I'm going to pause for just a second and go back to what I was talking about with the algebra stuff. I have worked this problem once before, and I initially grabbed this 3 and took it out of the integral to clean up my integrand just a little bit further. And it turned out that taking that 3 out made your values of a and b a little bit uglier. And I think if you leave that 3 on the inside, that it'll make your a and b a little bit nicer. I haven't worked it out that way yet, but that's how it looked when I worked this the first time. So I'm going to go with that heavy-handed method. I'm going to plug. I look at the underneath my 4, my a, and I notice that x equals 4 will give me a 0. So I'm going to go to my original fraction, and I'm going to block out the factor under the a, and I'm going to plug 4 into everything else. And if I do that, I get a is equal to negative 3 times 4, which is negative 12, over 2 times 4, which is 8, minus 5, which is 3, and we get an a value of negative 3. And so we did get a nice integer for a. Under b, I noticed that if I plug in 5 halves for x, I'll get a 0 in the denominator. And so b is going to equal, I'm going to take my box here, cover up my b factor, and I'm going to plug 5 halves into what's left. So that's going to be negative 15 over 2 divided by 5 over 2 minus 4. And so I'm going to multiply top and bottom by 2. That's going to be negative 15 over 5 minus 8, which is negative 15 over negative 3, which ends up giving me a b value of 5. And then once you have that, you can reset the integrals. And so now I'm going to have the antiderivative of a, which is negative 3 over x minus 4. And I'm going to separate these into 2 antiderivatives, plus the antiderivative of b, which was 5 over 2x minus 5. And the limits were negative 1 and 2. No, positive 1 and 2. So we're going to go from 1 to 2, 1 to 2. My children are waking up to come eat breakfast. And so I have negative 3 natural log of x minus 4 for that first integral. Evaluate that from 1 to 2. And this one, I think what I'm going to do is take this 5 out. Ungroup that. I'm going to take this 5 out here. And to make this a good natural log, I need to put a 2 on top and a 1/2 on the outside. And so I have 5 halves. Natural log, 2x minus 5. Evaluate that from 1 to 2. And then we'll have our answer here in just a minute. So we have negative 3. Natural log of the absolute value of 2 minus 4, which is 2, minus negative 3. Natural log of the absolute value of 1 minus 4, which is 3. So there's my first one. Brackets aren't necessary. It just makes me feel good being able to see the evaluation of each integral separate. And so then I have 5 halves natural log of the absolute value of negative 1, which would be 5 halves natural log of 1, which would be 0. So we could leave that one out. Plus 5 halves natural log of the absolute value of 2 minus 5, which is 3. And I will absolutely not attempt to simplify that in any way. There is my answer for part D. And this one is the one problem that I don't think you will see something like this on the AP exam, because they have said, and I mean on the 2020 AP exam, College Board has put out announcements several times saying that calculators, while they are allowed, you can use Desmos, you can use whatever you want, they're going to word the problems in a way that calculators do not give you a significant advantage. And this problem, a calculator would be a huge advantage when you get to a definite integral of an explicit function like this. Because at this point, right here that I'm circling with the pen, if you had a calculator, you would just throw that in the calculator and write down the answer. You would avoid all of the partial fractions. So while I think this is a really good question, I don't think it's very representative of what you would see on the AP exam this year. All right, so that brings us to D, and D works out kind of nicely. You want a third degree Taylor polynomial for k about x equals 1. They tell you that k of 1 is -1, and they tell you that k prime is f of x plus 2. And if you want a third degree Taylor polynomial about x equals 1, you have to remember that your terms are the nth derivative of f. No, this is k, not f. The nth derivative of k at 1 over n factorial times x minus 1 to the nth power. So I'm going to need, for a third degree Taylor polynomial, I will need k of 1, k prime of 1. I will also need k double prime and k triple prime. So let's go ahead and get k double and triple primes in terms of f, which technically is a chain rule. However, the interior derivative is 1, so we don't have to worry about it. K triple prime of x is going to be f double prime of x plus 2 times 1. And then to get the values, oh, now that was a very interesting, what the world just happened? Okay. Oh, I see. That's okay. Sorry. I was trying to get this out of the way and create a problem. So it's the nth derivative of k at 1. There we go. All right. So now I need to plug in 1 to these. So I need k prime of 1, which would be f of 3, which is 7. That was given. K double prime of 1 is going to be f prime of 3, which is the graph that's given. F prime of 3 is f prime of 3 is 2. And then k triple prime of 1 is f double prime of 3, which will be the slope of f prime at 3, which is -2. And so those are my numerators here, and we'll just slap that into our Taylor polynomial formula. And so it's -1 plus 7 over, I'll say 1 factorial, not really needed, times x minus 1 to the 1th plus 2 over 2 factorial times x minus 1 to the 2th, and -2 over 3 factorial times x minus 1 to the 3rd. And there is your third degree Taylor polynomial. So oddly enough, the Taylor polynomial problem was probably one of the easier ones here. So quite a difficult question. All right, I'm done with this.